Hello! Today, we're going to explore the history of Venus exploration and look at the important milestones and challenges in reaching it. Before we delve into the history of exploration, let me first talk about what kind of planet Venus is. Venus is the second planet from the Sun in the solar system and has a size and mass similar to Earth. However, its environment is very different from Earth's. Venus's atmosphere is primarily composed of carbon dioxide, creating a very high greenhouse effect that makes the surface temperature extremely high. This temperature reaches about 465 degrees Celsius, enough to melt lead. Additionally, Venus has a dense atmosphere and a retrograde rotation direction, and its planetary surface is composed of volcanic and similar terrains. The geological characteristics of Venus are as follows. The surface temperature is very high at about 465 degrees Celsius due to the strong greenhouse effect. Venus has many volcanoes, some of which may still be active. The surface of Venus is mostly made up of plains, and there are also some highland areas. There are many craters on the surface of Venus formed by collisions. These craters provide important clues for study. The geological changes of Venus. Venus's atmosphere is primarily composed of carbon dioxide and has very high pressure. Venus's atmosphere has very unique characteristics. Venus's atmosphere is mainly composed of carbon dioxide, about 96.5%, and nitrogen, about 3.5%, is next. There are also small amounts of sulfuric acid, water, argon, carbon monoxide, helium, etc. Because of the abundance of carbon dioxide, a strong greenhouse effect occurs, making the surface temperature very high. The atmospheric pressure on the surface of Venus is about 92 times that of Earth, which is extremely high. Venus's clouds are mainly composed of sulfuric acid, and it rains in the form of sulfuric acid. Venus's atmosphere rotates very quickly, a phenomenon called superrotation. As a result, Venus's atmosphere moves much faster than the planet's rotation speed. The superrotation of Venus, the rapid rotation of the atmosphere, is one of the unique atmospheric dynamics of Venus. The cause of this phenomenon is not fully understood, but according to various studies, it is related to the uneven distribution of heat received from the Sun in the atmosphere. This uneven heat distribution induces rapid movement of the atmosphere, causing the atmosphere at high altitudes of Venus to move much faster than the planet's own rotation speed. It is estimated that several factors that can cause this phenomenon work in combination. Let me tell you about the process of Venus research. The first astronomer to study Venus was Galileo Galilei. He first observed the phase changes of Venus using a telescope in 1610. Galileo's discovery suggested that Venus orbits the Sun, which was an important evidence supporting the heliocentric theory. This changed the astronomical understanding and perception of the universe at the time. In the mid-17th century, Giovanni Cassini first observed the atmosphere of Venus, and when part of Venus obscured the Sun, he inferred the existence of an atmosphere through the diffusion of light. In the late 19th century, astronomers began to measure the rotation, period, and orbital period of Venus, and started observing more detailed features of the surface. In the mid-20th century, radar mapping technology was used to determine the accurate rotation, speed of Venus, and to map the terrain of the surface in more detail. Shall we take a closer look at the major spacecraft that explored Venus and their achievements? Mariner 2. The first spacecraft to pass by Venus and perform scientific observations was Mariner 2. It measured the surface temperature and atmosphere of Venus and confirmed Venus's high-temperature environment. Venera series. From 1967 to 1983, the Soviet Union ran the Venera program. The Venera program included the first spacecraft to land on the surface of Venus. Venera 7 was the first spacecraft to successfully land on the surface of Venus in 1970 and became the first spacecraft to send data back to Earth. Venera 9 and 10 took and transmitted the first pictures of the surface of Venus. Pioneer Venus Project. NASA ran the Pioneer Venus Project in 1978. This project conducted detailed surveys of Venus's atmosphere and terrain. Pioneer. Venus 1 observed Venus's cloud layers and analyzed the atmospheric composition, and Pioneer Venus 2 dropped probes into Venus's atmosphere to collect direct atmospheric data. Magellan. The next project was Magellan in 1989. It was the first spacecraft to map the surface of Venus in detail using radar. Magellan provided important information about Venus's terrain, Volcanic activity and crustal movement. Venus Express. It was a spacecraft of the European Space Agency in 2005, which conducted detailed studies on Venus's atmosphere and greenhouse effects. It analyzed Venus's wind patterns, the chemical composition of clouds, and temperature changes. Akatsuki. It was a spacecraft launched by Japan in 2010, designed to study the weather and climate changes of Venus. Akatsuki has been observing Venus's atmospheric circulation and cloud movements and collecting important data. The exploration of these spacecraft greatly enhanced our understanding of Venus's environment and provided important insights into how the greenhouse effect developed to extremes on terrestrial planets. The next missions related to Venus by NASA are Veritas and Da Vinci, which are scheduled to be launched by the late 2020s and aim to map the surface of Venus in detail and analyze the atmosphere more comprehensively than ever before. These missions are important as they will further advance our knowledge of Venus's geology, volcanic activity, and atmospheric conditions. As for the possibility of alien life on Venus, scholars believe that it is difficult for life to exist due to Venus's extreme environment. The surface temperature of Venus is high enough to melt lead. The atmosphere is full of carbon dioxide, and it rains sulfuric acid. However, recent research suggests that there may be conditions in the upper atmosphere of Venus, where some life forms could survive. This discovery was made using ALMA Atacama, Large Millimeter Submillimeter Array and JCMT James Clerk Maxwell Telescope. If this gas cannot be explained by chemical or geological processes on Venus, it could suggest the possibility of life, especially the gas phosphine found in the atmosphere, which is related to biological activity on Earth, opens up this possibility. Thank you for watching. If you enjoyed this journey through the history of Venus exploration, don't forget to like, subscribe, and click the notification bell to receive more space content. Until next time, keep looking up.